And anyone in Zoom, you guys can put your answers in chat. So what factors do you think we should use for this? Any ideas? Yeah, 6 and 5. Good. Okay, so one thing you want to always be aware of is there may be a lot of times what happens is when someone gets stuck, they're focused on one set of factors. Like for 3 of them now, we had 3 and 10, right? 15 and 2. So sometimes you have to kind of expand your search a little bit. So 6 times 5 is 30, 6 plus 5 is 11, and we're good to go. So x times x plus 6 plus 5, and we're done. Okay. All right, so that is when you are doing a trinomial where a is 1. So now this is the last section, the last type of factoring, and this is when is not 1. So now you have a value here. Okay, so what we do, it's called trial and error. So this really makes you think through all the different factors. What's nice is we're going to check it by doing the outside plus the inside. So that's what that sum of OI means, the sum of the outside plus the inside. So first things first, what we're going to do is we're going to just throw in factors. So to get factors, what times what is 3b? Well, I can do 3b times b, because remember, this 3b squared is the answer of our f, right? When we're doing FOIL, first, outer, inner, last. And then factors of 4 is the last. So we can do, we'll just try some, 4 and 1. So another way to do this is you can write your factors up here. And thankfully, there's really only 2 sets of factors for 3b squared. For 4, we have a couple more choices. So we have 4 times 1, 1 times 4, and 2 times 2. Those are all our choices. Okay, so this is another term for this is guess and check. So you're literally guessing and checking. Guessing and checking. So what you're doing is you're trying to find this middle term. And you do that by multiplying the outside. So the outside is 3b times 1. So that's 3b. So that's this one right here. And then the inside is 4 times b. So this is the outside and the inside, this middle term. Okay, so we have 3b is the outside plus 4b is the inside. So 3b plus 4b is 7b. So this one is not going to work. We want it to equal 8b. Okay, so now we're going to try again. 3b and b. And we're going to use, we'll use 4 and 1, because do you see how the signs are now changing? So the outside is a negative 3b. The inside is plus 4b. So we get 1b. So this one doesn't work. So again, it's just a process of guessing and checking, trial and error. So we're going to go 3b and b, 4 and 1. So I'm just checking all the different techniques. Now, to give you hope, what's really nice about this is once you get that concept of outside and inside, this starts to get easier and easier and easier, because you're not going to use values that don't make sense. So outside is 3b. Inside is negative 4b. So that's a negative b. So that one doesn't work. And then we'll do the last one. So outside is negative 3b. Inside is negative 4b. So we get negative 7b. So that one's not going to work. So none of those work. All right. So now we can move on to our other set. So we can do, you can keep it as 3b and b if you want, or you can change it to b and 3b. It doesn't really matter which way you go with it. And then I'm going to try 2 and 2. We'll try 2 and 2. So I know that when I multiply the first, b times 3b, that I'm going to get 3b squared. I also know when I multiply the last, 2 times 2, that I'm going to get 4. So I'm good there. All I have to worry about is how do I get that 8b? So I have 2b plus inside is 6b. There is my 8b. Once you get it, you're done. You don't have to keep trying. All right, so it's just being able to use these factors that when I go the outside, 2 times b is 2b. The inside, 2 times 3b is 6b. When I add these, that's my sum. I get 8b, which is my middle term. So I know I did it right. I know I have it set up correctly. Okay, so it's a matter of just trying something, seeing if it works. If it doesn't, move on to something else. Yuritsa, what's your question? I can tell. You're mulling. Where's the 2? Yeah. Oh, so these are factors of 4, right? 2 times 2. So I just put them in the last position because 2 times 2, 2 times 2 is 4. Okay, so that's where the 2's came from. They're just factors. Okay, so the factors, so when I do 3b squared plus 8b plus 4, those factors are 3b plus 2 and b plus 2. So these can be written in any order. Notice I had them in an opposite order up here, but because my signs are the same, it doesn't matter. I can write it either way. They're both correct. Okay. All right. So it's not going to be as overwhelming as what this looks like. Right? Because you're going to be able to do a trial and error in a more succinct way. So we're going to rewrite this in descending order. So we have 6w squared minus 25w plus 4. Where is this acronym? Oh, this is just something, this isn't in your packet yet. Yeah, it's not in your packet. This is just something I put together to show it to you. The reason why I'm doing it this way is because the packet takes you right to solving and it doesn't show you how to factor. Yeah, it doesn't show you anything about factoring. So that's why I created my own. All right, so here is a great technique. To get 6w squared, I can go 6w times w, or I can do 2w times 3w. All right, everyone okay with those? Or I can flip-flop them. To get 4, I can use 4 times 1 or 2 times 2. So those are my options. All right. Now, here is one way to eliminate some options, some of the guesses, is you never want to have, I'm going to do it over here. You never want to have 2 values in a set of parentheses where a number can be divided out of it. So do you see how it has a common factor of 2? Right? Or I don't want to do 2w plus 2. That also has a common factor of 2. So what that does is it eliminates some of my options. Okay? So what that does is now I go, okay, I'm going to have my 6w and my 1 together and my w and my 4 together. So we're going to try it. So 6W and W and 1 and 4. Okay, now watch. I want it to equal a negative 25. So the only way to get a negative 25 is I need to have negative and negative. The only way to get a positive 4 is negative 1 times a negative 4. So I'm good there. So watch. 6 times W is 6W squared. 6 times negative 4 is a negative 24W. Negative 1 times W is negative 1W. And negative 1 times negative 4 is a plus 4. So do you see how I got my negative 25W? So with this one, it took me one step, one time of guessing. And it literally was a guess. I was just throwing values in. But I know, based on this concept over here, that I'm not going to put two things together that have a common value. So what that does is it knocks this one out. Because if I do 2W times or plus 2 or 2W plus this 2, it's going to knock that out. So my only option was the one that I used, 6W minus 1 and W minus 4. So if you ever have options that have a common factor, knock them out immediately. Oh, yeah, no, you're good. And this is where being up in front of you, I can use it with my hands. I'm going to do it. I'll be right back, Zoom people. This is really fun. All right, so this times this is 6W squared. Okay. Then the outside, see how they're on the outside of the parentheses? There's my negative 4W. The inside is negative 1W. And then the last two. And then you can FOIL on that one. Yes, okay, yeah, to check it. To make sure that you have set it up. Yeah, so it's outside plus the inside has to be this. Thank you. Show it on here. Right. I feel like it helps to have the visual, yes, yeah. Yes. So what I just showed, and I don't know if I can show it. Sorry, Zoom people. This irritates me. No end. You have no idea. Okay, so the outside and the inside. So this is our FOIL, right? This is that distributed property. So the outside is here times here. They're on the outside of the parentheses. So that's where I got the negative 24W. The inside is here. So negative 1 times W is negative 1W. I already know the first is going to work because I already have the factors. I already know the last is going to work because I already have the factors. Oops. Oh, darn. That wasn't good. Okay, so once you add your outside and inside, that should always be this middle term. And that's the goal. The first two, the first term and the last term is fairly easy because all you're doing is looking for factors. Where the real technique happens is the outside plus the inside. So it's always the outside plus the inside. All right. I don't want to give you one. Okay, we're going to jump down to number 5. And then we'll go back to, and again, this is not in your packet, so just do this on a separate piece of paper. All right, so 3a squared, our factors are 3a and a. That's all we can use. Our factors of 4 are 4 and 1 and 2 and 2. So those are the only factors that I can guess and check on. So first set of parentheses, I have 3a and a. And I want the outside and the inside to equal 1, a positive 1. So when I look, if I use the 4 and 1, so 4 and 1, I know I have a positive value of 4 and a positive value of 1. So 3a times 1, this is my outside and plus my inside. So that's my 7a, so that's not going to work. So then I'm going to try something else. Oops. So I know 3a and a is the only way to get 3a squared. So that's the only thing that I'm going to leave. So now I'm going to do 1 and 4. So the outside is 12a. The inside is 1a. That's 13a. So that doesn't work. So now I'm going to do 2 and 2. So 3a times 2 is 6a. The inside is 2a. That's 8a. So that doesn't work.
You're trying to get 1, right?
I'm trying to get it to be 1. Mm-hmm.
Okay, so that-
No, because there is a 1 there. There's always a 1 in front of a single term. But this is one of those examples, and I wanted to make sure that you saw this, that sometimes you can't factor it. Sometimes it's unfactorable. If you have used all the different combinations, so let's say we did we do 1 and 4? Yeah, we did 1 and 4. We did 4 and 1. And we did 2 and 2. So that's not going to make a difference. So this one would be considered prime. So that's your 7th type of factoring. Now, I can guarantee you, you will have very few of these, if not any. Okay, so when it is prime, when you can't factor it, then you're going to go back to the quadratic formula. So remember, there's 3 different methods to find x, or the variable: quadratic formula, factoring, or the square root method. Okay. All right, we'll try this last one, and then we're gonna switch gears. We're gonna add 1 layer to it, and all that is okay. How do we find what the variables represent? So 2y to the 4th is 2y squared times y squared. That's 1. Or you can do 2y cubed times y. Those are the only ways to get 2y to the 4th. So 15. Now we have a few more options. Oh, and it's negative 15, so make sure you put that in there. So for it to be negative 15, you know, 1 has to be negative, 1 has to be positive. You know, it's the larger one's going to be negative because of the negative right there. So that kind of limits what the values are. So we're going to go 2y squared and y squared. We're going to try that first. Okay, so kind of look at your factors of 15, and you can kind of do it in your head. You can go 2 times 15 is 30. So that's way too big, because 30 and 1y squared, that's way too big. You could go 2y squared times 5. So if we did 5 here and 3 here, And we know it's going to be a -5 and a +3. So 2y squared times -5, that's a -10y squared. That's your outside. And the inside is 3y squared. So that's -7y squared. So that doesn't work. So we're going to switch this now. So we're going to go, oops, -5 and +3. Okay, so here we go. 2y squared times 3 is 6y squared. -5 times y squared is -5y squared. Do you see how we're getting closer? We need it to be a -1. So what can we do? What could we change to make it -1? Is there any way to get it to be -6y squared plus 5y squared? That gives us a -y squared, which is what we want. So how can we get this? Yeah, switch the signs. That's it. So sometimes it's okay to switch the sign because the goal is that middle term. So when you put in your sign, don't be locked in that it has to be that. Sometimes, and it's because we're using a value on the front end of our polynomial. Okay. Now, here's the good news. You're not going to see a lot of these. The majority of them are going to be the trinomials, factoring greatest common factor, and factor by grouping. That's funny. Okay, so and then the two special ones, the perfect square trinomials and the difference of two squares. Those are going to be the ones that you're going to see the most of. Okay, all right, so how do we get to solving? So remember, with quadratic formula, we found what x is, because remember the quadratic formula, write it up here, was x equals -b plus or minus square root of b squared minus 4ac all over 2a. You were looking for x. You were finding what the x is. Well, what you're actually finding is where the parabola crosses the x-axis. That's literally what you're finding. It's where does the ball start and stop? Okay, where does the profit start and stop? That's what you're finding when you're solving for x with factoring. So there's something called the zero factor theorem. So, and what that says is if you have two things that you're multiplying together and they equal 0, what that means is either A equals 0 or B equals 0, which makes sense, right? It's one of those logical things. Oh, if I'm multiplying two things together and it equals 0, one or the other has to be 0 because 0 times anything is 0. Okay, so what that means is when you factor something, so let's say we have something like this one. Let's look at this one. So when I factor this, I get x times x minus 4. If I set this to 0, move this up. If I set this to 0, what this means is either x equals 0 or x minus 4 equals 0. All right, well, this is already solved. We already know x can be 0. This one, I just have to solve it. I do my one-step equation. So x equals 4. Yes, sorry, this is page 159. Yeah, 159 in your math packet. Okay, so What that means is your x-intercepts are at 0 and 4. That's where your parabola is crossing your x-axis. Okay, now I can put this in the quadratic formula and get the exact same answers. So the quadratic formula will work on any quadratic, anything that has an x squared in it. Your quadratic formula will work. I've had students who really struggled with factoring, but they were really good at the quadratic formula. And so they use the quadratic formula every single time to check their factoring, to make sure that they were factoring correctly. Okay, so what this means is when you have something that's already factored, if this equals 0, so this is page 160, if this equals 0, all you're going to do is you're going to take each factor and set it to 0. I take my x minus 5 factor, set it to 0. And I take my x plus 2 factor and set it to 0. And then I solve. These are just one-step equations. Okay, so what that means is I have an x-intercept at -2, and then another one at 5. 1, 2, 3, 4, 5. This is where my parabola crosses my x-axis. So it's just a little sketch. How do I know it's going up? Because remember, it's positive in the front. So my A is 1, or my A is positive, so I know it's going to be a copy face. I know it's going to go up. All right, try the next one. You have x plus 6, x minus 6. Go ahead and solve. Set both of those to equal 0 and solve, and then graph it. Nathan, this is page 160 in your packet. You're welcome. Weren't you in an interview, Nathan, today?
No, it wasn't an interview. I already got the job. I was just at an HR appointment that I
Oh,
needed to do.
gotcha. Okay, trying to figure out how to get your first check, right?
Mm-hmm.
Yeah.
Yes.
What
Thank
job
you.
is it?
It's for a patient care technician on the research
Oh,
unit at
okay.
Methodist Hospital.
Oh, very good. Is it the one? Is it the one off of 10?
I'm not too sure. I just know that it's like the main hospital.
Okay. If it's the big Methodist hospital off of 10, my son-in-law is the ER coordinator during the day.
Oh, that's cool.
His name is Tom. He's a very nice guy. He's very helpful. So go look him up.
Thank you.
He'll be thrilled that his mother-in-law is your math teacher.
I'm sure he will.
All right, so here we go. We're going to subtract 6 from both sides. So x equals -6. We're going to add 6 to both sides. So these are my two x-intercepts. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And it's positive, so it's going to do something. We don't know where it's going to cross. We'd have to multiply that out. Oh, in front. Sorry, I couldn't remember. Right here, if there was a minus sign here, then it would be down. If it's a positive, then it would be up. Yeah. Okay, so any questions so far? Okay, so here is one of those trinomials where A is not equal to 1. So they already factored it for you. Okay, they already figured out that, oh, the factors are 2x minus 3 and 3x plus 4. And so then they solved. So when you solve and there's a two-step equation, don't let that throw you. You guys already know how to do two-step algebra. So you're going to add 3 to both sides. And then you're going to divide by 2. There's your 2 steps. So this one, the x-intercept is at 3/2, which is 1.5. And then this one, we're going to subtract 4 from both sides. And then divide by 3. So x equals negative 4/3. So it's negative 1 and 1/3. So there's your 2 intercepts. Here's negative 4/3 and here's 3/2. Okay. So that's the most you'll have to solve. Here's a little hint, and hopefully you'll see it as a pattern. So whenever if we go back to this one, right, and we set both of them to equal 0, because of the method of algebra solving, you subtract, you use the opposite. Notice your answer is always the opposite sign. Okay, if I do this one and I add 6 to both sides, my answer is always the opposite of what I've given because of that technique of you're adding the opposite. It's the same thing when you have a two-step equation. If I add 3 to both sides, that changes the sign, and then I'm dividing by whatever is next to my x. So it's going to be the opposite sign over. So if I had 4x plus 3 equals 0. I can do this real quick. I'm going to subtract 3 and divide by 4. Okay, so I just want you to be aware of it. If that's too much information and you don't see it right now, that's okay. You have the technique. You are gonna subtract or add and then divide. Subtract or add and then divide. That's how you'll do every two-step equation. Okay, and then notice my answer is the opposite sign of what I'm given every single time. All right, so here's how this works. Now we have all the techniques mixed up. This is where you have to decide, all right, what's the best technique to factor? Okay, so this is the difference of 2 perfect squares. So I recognize it, I see it, I go, okay, it's 2 sets of parentheses that always will equal 0 now. So when you see it equals 0, now you have to solve for it. Square root of 9x squared is 3x. That goes in the first position. Square root of 16 is 4. That goes in the second position. 1 is plus, 1 is minus. Difference of 2 squares. And it's just a visual. Do I see it? Okay, so now I'm going to set both of them to 0 and solve. And I know to do that because of my equals 0. My equals 0 tells me, okay, now I have to actually solve. So I subtract 4. And I divide by 3. So x equals negative 4/3. And then this one I add 4. And then divide by 3. So there are my 2 answers. Negative 4/3, positive 4/3. And hopefully you'll get to the point where you won't even need to do this. You can look at your 2 factors and go, okay, one's negative, one's positive. That means my answer, one's negative, one's positive. Okay. All right, number 2. So if you notice, it has to equal 0 for this to work. Okay, so we are going to move this 9 over so that we have a trinomial that equals 0. And the reason why it has to equal 0 is because you can't use that 0 factor property or theorem unless it equals 0. Because there's a million different ways for it to equal 9. You could have 4 and 5, 1 and 8, 2 and 7, 6 and so on. All right, so here we go. What do you there? So this is your A is 1. So what do you multiply to get 7? Add to get 8. The only factors of 7 are 7 and 1. So it's going to be x plus 7, x plus 1. And this is that idea that outside plus the inside. 1x plus 7x is 8x. So I know I did it right. And because it's equals 0, I have to set both of them to equal 0. So my x is going to equal a negative 7, and x is going to equal a positive, oops. Oh, I wrote it wrong, sorry. That's plus 1. So they both equal negative. Negative 7, negative 1. So when I subtract 7, subtract 1. And also knowing that you're going to have an opposite sign, that's how I caught this, is because I know that I had to have an opposite sign. So it's a quick check to make sure that you're doing it correctly. So negative 7, negative 1 are your x-intercepts. Exactly. And then you'll factor it. Yeah. Okay, so like on number 3, it equals 2 minus 7x. So I have to bring all of this over. So I'm going to subtract 2 from the 5, and then I'm going to add 7x. So I end up with 2x squared plus 7x plus 3 equals 0. So I'm just moving everything to the left side. Okay, so I'm going to do this over on the side just because I'm running out of room. So it was 2x squared plus 7x. What was the last number? Plus 3 equals 0. Okay, so this is our where a does not equal 1. So our factors of 2x are 2x squared or 2x and x. Factors of 3 are 3 and 1. So this makes it nice and compact. I know first position is going to be 2x and x. Now I just have to arrange my 3 and 1. I want it to equal 7. So if I do 3 out here and 1 here, I get 6x plus 1x. There's my 7x. Okay, now just to show you, had I switched it, had I put 1 here, wait, where did I have 3? Had I put 3 here and 1 here, here's 2x plus 5x. 2x plus 3x is only 5x. Okay, so that's why it has to be 1 here and 3 here, because 2x times 3 is 6x, 1 times x is 1x, so 6 plus 1 gives me 7. So 2x plus 1 equals 0, x plus 3 equals 0. So my x is going to equal -1/2. And my x is going to equal -3. So all I'm doing is just switching my sign. So I'm subtracting 1 and dividing by 2. And then here I'm subtracting 3.
So you put all of that collectively equals 7x.
Yes, yeah, so this is that outside, right? So there's my 6x, 2x times 3x, plus my inside. So 6x plus 1x has to equal 7x. And that's how you know that your factors are correct, that you have all the right numbers in the right position.
So like we do have
In the middle, yes. Yeah, yeah. Because the first, there's only, one set. The last, there's only one set. So it's only the middle that you have to worry about. So it's the outside plus the inside. Okay. All right, let's do another one like that. Where do we want to go? Okay, here we'll do this one. All right, so would you rather just keep practicing that particular kind? Trying to see if I can find one like that.
what is this one called? Like what is it?
So this is the trinomial where a does not equal 1. Yeah, that's that trial and error. I'll guess and
Right.
check. Oh no, you're good. Yeah. Yeah, that's the thing. They don't give you a whole lot to practice on, which is unfortunate. 15, okay, 13 works. All right, so we're going to set it to 0. So instead of moving the 2 terms to the left, we can move the 1 term. Actually, let's move it to the left because we don't want a negative in front of our x squared term. So sometimes you have to be strategic. So we're going to move our 4x squared over, minus 11x plus 6 equals 0. Okay. Then our 4x squared, we can do it as 2x times 2x or 4x times 1. Our 6, we can do it as 1 and 6, 2 and 3. So this is where you want to really pay attention. If I do 2x and 1, I'm okay. There's no common factor. But 2x and 6, there's a common factor. So I can't use that one. If I do 4x and 4x and 2, that's a common factor. So with this one, I'd have to do 4x and 3 in the same parenthesis. And 1x and 2, 1x and 2. Okay, so remember, you don't ever want to put in the same set of parentheses anything with a common factor. So don't write this down, but let me show it to you. If I do 2x and 2x, and I do 1 and 6, do you see how there's a common factor here? So that's why I can't do that one. Well, if I switch it, if I do 6 here and 1 here, I'm still going to have a common factor. So this set really doesn't work for me. So it knocks that set out. So I don't even have to worry about that. But it's being able to visually see it and go, oh, okay, I can't have that. So now I know I can use 4x and x. Again, the 2 can't be with the 4. They're kissing cousins. They can't be with each other. So the 2 has to be over here, which means the 3 has to be here. Okay, so now look, 4x and 2x, that's 8x, plus 3x, there's my 11. I want it to be a negative, so that means everything's going to be negative. So the outside is negative 8x, the inside is negative 3x, that equals negative 11x, I'm good to go. So it's like a puzzle. If you like puzzles, you'll like these. And it really does force you to know your factors. So I'm solving for x, so I get x equals 3/4, which makes sense, right? The opposite of 3 over 4. And then I add 2 to both sides. So x equals a positive 2, which again makes sense because it's the opposite of negative 2. So always remember what you're finding. What you're finding is the x-intercepts. That's what you're finding is the x-intercepts. It is. It is. Okay, so let's rest your brain just a little. Just a little. Let's go up to number 4. All right, so what we're doing is we are eliminating the fraction. We do not want to deal with fractions. So what will both 9 and 3 go into? Not what will go into it, but what they will go into. So 9 and 3 both have to go into 9. Yeah, so it's usually the larger number. 3 goes into 9, 9 goes into 9. All right, so 9 goes into 9 one time. 1 times 9 because it doesn't have anything. And 3 goes into 9 3 times. And remember, what you just did is you just eliminated the denominator. So 1 times x squared is x squared. 9 times 1 is 9. And 3 times 2x is 6x. So when you set everything to 0, you have x squared plus 6x plus 9 equals 0. So if you see it, do you remember perfect square trinomial? First term's a perfect square, last term's a perfect square. Okay, so if you see it, that's great. Or if you don't see it, your a value is 1. So what do you multiply to get 9, add to get 6? So you can do it either way. Let me see. You might be right, Nathan. Yes, because we brought over the 6x. Good catch. Thank you. Good catch. So Nathan says the 6x should be a negative, and he is absolutely right. Because when you bring your 6x over, it becomes a negative 6x. Okay. So the only way to get a positive 9 is negative 3 times negative 3, or 3 times 3, and the only way to get negative 6 is negative 3, negative 3. So you can write it either way. So if you see it as a perfect square trinomial, it's going to be x minus 3 squared equals 0. If you see it as a trinomial where a is 1, it's going to be x minus 3 times x minus 3. So either way, your answer is x equals 3. So this is the one type of instance where your parabola only has one x-intercept. And so basically what it does, if this is x is 3, your parabola comes down, it touches it, and then goes back up. So it hits it at one place. Okay, so that's why there's only one answer instead of 2. Normally there's 2 answers. Yes, so that would be your vertex. Yeah, your minimum. Yeah. Good catch. Okay, so 5 and 6, what you're looking at is trinomials But if you notice, they all have an X in common, right? For number 5, the numbers, there's no number that's in common to each. If this was a 5, then 5 would be in common, but there's only an X in common. So this is that idea, you factor out a greatest common factor first. And then I'm going to rearrange it so it goes in descending order. So hopefully you always pay attention to the first and the last term, the A term and the C term, because that's going to save you a lot of frustration. A lot of people will look at this and go, okay, it's a trinomial where A is not 1. And so then you have to go through that whole guess and check scenario, right? 4 is 4 and 1, 2 and 2, 25 is 1 and 25, 5 and 5, and there's a lot of guessing and checking. Or you look at this and you go, oh, perfect square, square root each one, and square the whole thing. And don't forget the X in front. So much easier if you recognize that it's a perfect square trinomial. Just square root the first term, square root the last. Use the first sign and square the whole thing. All right, so now because we're solving, because there's an X out here, X equals 0, that's one answer. The other one is 2x plus 5 squared equals 0. So to solve it, you're going to square root both sides. And all that does is it pulls out the 2x plus 5. Because remember, something squared, the square root of something squared, these cancel each other. That cancels that. So it just pulls that 2x out, 2x plus 5 out. And then you solve. So I had x is 0 and x equals negative 5 halves. Those are my two values. And then number 6, same idea, but this time there's not a t on my 36, but what is in common between all those numbers? 2, good. So I'm going to factor out a 2. It's all right. 36 divided by 2. All of a sudden I hit a blank. Oh my gosh, 36 divided, I keep doing times 2. Yeah. Okay. All right. So now we no longer have a value on the t squared. So a is 1. So what do you multiply to get 18? Add to get 9. Good. 3 and 6. Perfect. So t plus 3, t plus 6. So your t values are going to be opposite sign. So negative 3, opposite sign, negative 6. The 2, because the 2 does not have a variable next to it, that because you can't have 2 equals 0, right? So this just is basically what this is saying is it's this parabola twice as big. That's all that means. It's doubled in size. Where this one, you had an X, so you had to find out what that X value is. So it has to be 0. So if there's no variable, you don't have to worry about it. Okay, everyone good with my negative 3, negative 6? Okay, so all I did, just in case, is I set each to 0 and then subtract. oops, subtract. And hopefully you'll get to this point where you don't even have to do this step. You just see it, go, oh, it's -3, see it, oh, it's -6. All right, we love fractions. Let's practice another fraction one. So what does 5, 4, and 10 all go into? Good. 20, perfect. So 5 goes into 20 4 times. Get rid of my denominator. 4 goes into 20 5 times. Get rid of my denominator. And 2 goes into 20 twice. Get rid of it. And now I multiply. 4 times x squared is 4x squared. 5 times x is 5x. And 2 times 3 is 6. So I'm going to bring that up. Okay. So now we have to do guess and check because there's a 4 there. So I'm going to start with 4x and x. I want it to equal 5 in the middle. And I want -6 as my factor. So if I did 3 and 2, that's 12 and 2, so that's only 10, so that's not going to work. If I do 6 and 1, that's 24 and 1, that's not going to work. If I do 2 and 3, so there's 8 and 3, that'll give me 5. So if I do 8 has to be positive, and then 3 has to be negative. So 8 minus 3 gives me a positive 5. Okay, so again, that's that whole idea of the outside and the inside has to equal this middle term. So you just keep manipulating and guessing those factors until you get it to set up to be 5. All right, so we have 4x minus 3 equals 0. X plus 2 equals 0. So x equals -2 and x equals positive 3/4. Okay, and then I do want to get, sorry, I don't mean to make you sick. Okay, I do want to get, so this one here, this number 12, because t squared is by itself, right? So this is where we can use our square root method, right? When t squared is by itself. So divide both sides by 16. 49 over 16, and then we square root both. So I get t equals 7 over 4, and t equals a -7 over 4. So don't forget, every time you square root, it's a positive or a negative. Okay, I'm going to move this a little bit. So I'm going to leave these. You guys have all the answers in the back. I would strongly suggest that you practice until you cannot practice anymore. All right. So solving equations by factoring. So this is page 163. So what you're doing is now you're putting it all together. The only difference is now you can find the x-intercept. So remember before it was the number of x-intercepts, 0, 1, or 2. Now you're going to actually find them. Okay, so that's the difference between the two, between what we did before and what we're going to do now. So here we go. First term is positive. So we know it's gonna look like that. So it opens up. Axis of symmetry and vertex. So we always find our vertex because that answers both of those questions. So remember, it's the x value equals negative b over 2a, and the y value means you plug that back in. So it's x equals negative 8 over 2 times 2. So negative 8 over 4 is negative 2. And then the y value, you're going to plug that back into the original equation. So this is 2 times 4 is 8, minus 16 equals negative 8. So our vertex is at negative 2, negative 8. Our axis of symmetry is the x value of our vertex, so x equals negative 2. So our axis of symmetry is going to look just like that. And our vertex is at negative 2, negative 8. And we know it's going to go up. Okay, and our y-intercept is at 0, whatever c is. So all of these are, I'm reminding you. So in this case, our c is 0, because we don't have one. So our y-intercept is here, which in this case, do you see how it's also an x-intercept? So let's prove it. So the x-intercept we're going to factor or use the quadratic formula. But in this case, factoring is super easy. So we can factor out a 2x, and we get x plus 4 equals 0. So this is, put a star right here. This is what we're doing right here. Okay, so we're going to set both of these to equal 0 and find our x-intercepts. So this is 2 times something equals 0. Well, that something has to be 0. So we already have this one. And then this one, we subtract 4 from both sides. So our other x-intercept is at negative 4. So our x-intercept is at 0 and negative 4. So we come over here. Now, this is where you can check to make sure that you're doing it correctly. The y-intercept is 2 steps away from my axis of symmetry. That means I have another point 2 steps away. So this totally works. If for some reason, let's say I did this and I messed up and I said that this was 2, and so I said that my x-intercept was at negative 2, do you see how it is not symmetrical anymore? Because then I have a parabola that looks like that. So your answer should always, oh man, always make sense. So your parabola looks like that. So with this one, the domain is always positive, negative, infinity. The range is based off of your vertex. So remember, you're scanning, it starts at negative 8 and it goes to infinity. Just in case, I'll have to look and see, just in case they show your x-intercepts this way, right? It's a point, it's the address, 0, 0, and negative 4, 0. But this way is fine too, if you just give me the what x equals. Okay, so that's the only difference between what we were doing before and what we're doing now. So on the test, just be aware of this. On the test, you have one question that asks, number of x-intercepts. And the other question that says, what are the x-intercepts? So you'll see one that looks very similar to this. Just notice what it's asking for. Is it the number of x-intercepts or is it the actual x-intercepts? Which means you have to factor, quadratic formula, or solve one way or the other. Okay. All right, so you're good there? Okay, all right, so word problems, not an issue anymore, right? When it asks for how long, it's asking for the x-intercepts, right? When does it start and stop? When it's asking when is the rocket 112 feet high, what that's saying is, oops, the height is 112. So this is the y value. You're looking for the time. That's that when question. Okay, so if you're looking for x-intercepts, you can either factor or you can use quadratic formula. So factoring, I'll do them both. Factoring looks like this. So negative 16t squared plus 128t equals 0. So I can factor out a negative 16t and I get t minus 8. So set both to 0. So negative 16t equals 0. So t equals 0. Makes sense. It started at 0 time. And then t minus 8 equals 0. And solve. So t equals 8. So how long is the rocket in the air? It's in the air for 8 seconds. Right? So if this was where it took off, and then it landed 8 seconds later. There's your x-intercepts. That's what you're looking for. And then if you do this quadratic formula, it would just look like this. I won't solve it because we already have the answers, but just so you know. Oops, so when you work all this out, you'll get the answers 0 and 8. But either way, you can do it either way. It does not always have to be factoring. If you're better at the quadratic formula, do the quadratic formula and then see if your factoring skills work. Okay, and then when is the rocket at 112 feet high? So you're going to set it up this way. So the height is 112 because that's what this means, right? H of t means height. So that's how you know where to put that 112. And then you're going to set this to 0. So we're going to subtract off our 112. So we get negative 16t squared plus 128t minus 112 equals 0. And then I always check to see if I can divide off this first term because it makes it much easier to factor. So I can divide. I just divided 112 by 16. And so I know it works. So I get t squared minus 8 plus 7 equals 0. And now you can see it's super easy to factor. What do you multiply to get 7? Add to get negative 8. Well, it's got to be negative 1 and negative 7. So we have t minus 1 and t minus 7. So the rocket is in the air it's at 112 feet at 1 second. And then again at 7 seconds, which makes sense, right? If our rocket leaves at 0, it goes up and then comes back down 8 seconds later. Well, 112 is at 1 second and 7 seconds. So it does have to go up and then come back down again. It's called gravity. Okay. So this one, quadratic formula, zero factor, and then is there a difference between the two? Just remember zero factor property, that's at zero factor theorem, so you're just setting both to zero, so that doing this, I'm just looking to see. Okay, that was it. All right, so the review, we're only going to spend a little bit of time on there. Is there any particular review you want to look at? So what I did is I broke it up by homework. So that way you can go back to that particular homework and review what you need to do. So homework 10 is just adding, subtracting, multiplying polynomials. Okay. The biggest key with subtraction is make sure you push that negative to both. So it becomes 3x plus 1 plus 2 minus 3x plus 2. So that way you can add your like terms. So this all ends up being 4 because the 3x's go away. So that's something to make sure you pay attention to. Another thing to pay attention to is when you have something squared, what this means is 3x plus 2 times 3x plus 2. Actually multiply it out and use the distributive property or FOIL, whichever one you prefer. Okay, so again, notice there's no sign in between, so that means you're multiplying, as opposed to when there is a sign in between. That means you're adding. So just pay attention to those. And then factoring greatest common factor, just look, what do they all have in common? So like this one has a 9x cubed in common. So you're actually dividing. 36 divided by 9 is 4. The x cubes go away. 90 divided by 9 is 10. 5 minus 3 is x squared. And 72 divided by 9 is 8. And then remember, because you're dividing exponents, you're subtracting the exponent. So 7 minus 3 is 4. And that's it. That's all you can do for those. Okay. So just go back and look at each homework and make sure that you're comfortable with the material. And then homework 11 is functions and functional notation. So just remember, this means replace x with whatever's inside the parentheses. So this would be -2 squared plus 2 times -2 plus 1, and then simplify it. So the 4's cancel, so you end up with 1. So that's what this means. This is the y equals 0. So this is, you're going to set your f of x to 0 and then solve. You're going to solve for x. And this you can factor. So even though at homework 11 you didn't know how to factor, now you do. So this one would be a perfect square trinomial. So x equals -1. Okay, so just know the difference between the two functional notations. When there's a number within the parentheses, that is what the x is. When there's a number outside, that's what your y value is. Or look at it this way, f of x equals 0. Look, here's your f of x here. Just change it to 0, and then you have it. Okay, and then be able to read a graph. That was another thing, being able to read a graph. So again, if it's inside, that means that's what the x is. So you come over here to x is 1. So your y is 0. This is X is 2, so you come down here and you just kind of give a good guess as to what you think it is, about -2. This one says when X is -3, you come down, looks like it's about -4. And this one is what gets people more often than not. This means when the Y is 0, right? So f of X is just another way to say Y. Well, you have to really pay attention. Y is 0 here, 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 and here. So there's going to be more than one answer with this one. So you're finding X. So X is -4, -2, 1, and 4. So it's all of them.
Are we allowed to do
Yes,
it? Are we take it in person?
yes.
Last time it was just the internet.
Right. Yeah, yeah. The internet happened to be out that day. So. Okay, all right. So then homework 12 is just applications, being able to read a word problem, set it up. So remember, cost function is the fixed cost plus the variable cost. So in this case, initial fee is your fixed. 120 per month or a month, that's your variable. So it's going to be the cost is the fixed plus the variable. Oops. 115 times X. And then make sure you notice what the X represents. It's per month. So at the end of 1 year, that's 12 months. Okay, so you'll get a very different answer if you plug in a 1. So those little details are what's gonna make or break it. And then you can calculate that. Okay, and all of these are worked out in Canvas in the solutions. So you can kind of go back to it. And then being able to know what each part is. So the y-intercept is here, that's your fixed. The slope is an increase in cost per month. So just being able to identify what is what. And then again, because it's per month, 2 years is 24. So it's going to be $5.99 times 24 plus 99. And then you'll calculate that. And then homework 13, this is what I was talking about. See, it says number of x-intercepts, 1, 2, or 0, 1, or 2. But everything else is the same. Being able to use your, find the vertex using the vertex formula, domain and range. So that's the only difference between what we did today and homework 13. Okay, and then same thing. And then 14, same thing. Looking at a word problem. This is homework 14, just the application. So notice what your variables represent. H is the height in feet, and the T is the time in seconds. Okay. And then where does the height, what's the height where the rocket starts? It's always your C value at 80 feet, good. And then when you see the term maximum, what's the mathematical process you're going to use? What do you look for? The vertex, yes. Okay, so you're going to use your vertex formula. So that might be something you want to put in your notes. Maximum or minimum, equals vertex formula. So every time you see the term maximum or minimum, you know you're going to use the vertex formula. And then when does the rocket reach 100 feet? That's where your Y or your H of T is 100. So you're going to set that up, and then you'll set it to 0 and then use the quadratic. Okay, and then the last 3 homeworks are all finding, all of these are finding your x-intercepts. It's just 3 different methods. Okay, so in the test, I'm going to ask you, you'll see a question just like this. Solve using the quadratic formula. And then it'll say solve using the square root method. And then it'll say solve by factoring. And then it says solve using method of your choice. So then you can decide which method to use, but you have to show that you can do all 3. Okay. So for this one, you want to set it to 0 first. And then, so that way you know what your A, B, and C is. If you don't set it to 0 first, then your C or whatever value is to the right of your equal sign is going to be a different sign. So negative 24 plus or minus B squared minus 4 times A times C. All over 2 times A. And again, this is what your X values are. So another thing, I just want to mention it one more time. When I do this part right here, I don't pay attention to my negatives or positives until I get the answer. So I go 4 times 8 times 14 is 448. And then I look, there's 2 negatives, which makes the whole thing positive. It just makes your life easier. Much easier, yeah. And then we go from there. So this is, so again, you're going to have 2 answers, 24 plus 32 over 16 and 24 minus 32 over 16. So make sure you have 2 answers. And on your test, I want you to show everything. Show that whole thing. Show what you plugged in, what the answers were as you went. Square root of 1024. On your calculator, right above the x squared button, you're going to do shift, hit that, and then 1024, and then enter. And does it give it to you, or does it keep it in quadratic format? Okay, all right. Okay, and then just real quick, square root method, we already did this on your, so we get x squared equals 25 over 4, and then square root. So we get plus or minus 5 over 2. So remember, you just split it up. Square root of 25 is 5, square root of 4 is 2. Don't forget the plus or minus. Okay. And then factoring. What do you multiply to get 30? Add to get 13. It's going to be -3, -10. And so x equals 3 or 10. And factoring just takes practice. That's all it is. And I'm gonna leave these so we can, guys can head out. I'm gonna leave these last. I think there's a bunch. So these are all worked out. Most of them you've seen before. A lot of them you've seen before. This 29 got people, right, Annalie? This one is prime. This one cannot be factored. So once you see that it's prime, go right to the quadratic formula. Don't spend a lot of time. If oh my gosh, how do you spell form? ULA. Don't spend a lot of time if you're seeing something it's hard to factor, just jump right to the quadratic formula. It works every single time. Every single time. Okay? And then that's it. All right, any questions? So Tuesday, you'll come if you, Yuritsa, I know we had talked about if you want to take your test from home. So just has to have your camera on is all. So make sure your camera is on when you come to class on Tuesday. If it's not, I will have to remove you from class because I want to make sure it's you taking it, taking the test. Otherwise, have a great weekend and I will see you on Tuesday. Yes, you can print the review, Nathan. And I'll post the just about 15 minutes before class starts so you can print it if you want it. Yes.